calloc. This function is useful for allocating multiple blocks of memory. Malloc will allocate the single block of memory. Calloc will allocate the multiple block of memory. It is declared with two arguments. Only difference between the malloc and calloc is that malloc allocates the single block of memory address, whereas calloc allocates the multiple blocks of memory, each of the same size, each block of the same size. Okay, set all bytes to zero. Initially, it will set the all bytes to zero. Okay, this is syntax ptr equal to data type star integer star then calloc and n comma byte. We can say that in very clearly. We can say that it is a data type. The syntax data type star calloc n comma then byte in size. What I am doing, I'm allocating memory integer star calloc 4 comma 2. So for about declaration allocate 4 blocks of memory, each contain 2 bytes. Their base address is stored in the integer pointer. The free function, this function is used to release the memory allocated by the memory allocation function. Okay, free you send the pointer inside, it will release the memory. Okay, then we'll discuss a program. Let us say program to, okay, the CLR function. Write a C program to find the sum of elements entered by the user. To perform this program, allocate the memory using CLR function. You can allocate the memory using CLR function, and actually you have to perform the sum of the numbers. Okay, we'll see the program. CLR example one, sum of the numbers. I mean, yesterday we got standard put output library and yesterday lib.h. Integer number is integer variable, I is integer variable, star ptr is a pointer variable, sum equal to another integer variable. I ask the user enter the number of elements. I store it to the variable num using scanf statement. So pointer equal to integer star calloc. Okay, number of elements, comma size of integer. What it will do? It will allocate like number of blocks. Okay, 4 elements means it will four block of each block contain the 4 bytes. If ptr equal to null, that means memory is not allocated. Okay, memory is allocated, the base address will be written. Memory is not there, memory is not allocated, then it will have a null value. So ptr equal to null, error, memory is not allocated, and we are giving exit. So then if memory is not null means what it means? Okay, definitely base address is returned to the pointer variable. So enter the elements of the array. I printed to user for I equal to 0, I less than number is a total number of elements, I plus plus. I am increasing it as a I plus plus loop variable. So scanf, I ask the user to enter the number. So scanf percentage d ptr plus I. So initially element will be stored in the base address. I's value is 0 ptr. Then actually it will be stored in the sum. Sum equal to dereferencing operator. Ptr plus 0 equal to base address. Okay, the value entered is stored in the sum. Okay, so sum's initial value is 0. Now I is become 1. Ptr plus 1, it will point the next element. Okay, scanf ptr plus 1, it will stored in the next memory location. Okay, here what will happen? Sum equal to first element value already there in sum. Sum plus equal to means sum equal to sum plus. Okay, then pointer plus 1. Okay, next memory address, it will be stored in the sum. Then what will happen? I is become 2. It will come inside ptr. User will enter ptr plus 2. So third element will be stored in the base address plus 2. And when we reference after ptr plus 2 means, okay, the third element will be retrieved and stored in the sum. Likewise, okay, until 0 to n, now num minus 1 loop will go. All the elements are okay stored in the consecutive memory location, as well as they are retrieved, and their value as their value sum is stored in the variable sum. So after printing that, what I'm doing that, I sum equal to percentage is I'm printing it, and actually I'm freeing the point variable. I'm please, okay, after I'm using the memory allocated for the calculation. After calculation is over, I'm freeing the memory. That is the advantage of you're allocating and deallocating memory at runtime. The memory is used for some other purpose. We'll run the program and check the result. Number of elements 4. I'm giving 1, 2, 3, 4. The value is 10. 4 plus 3, 7, 9, and 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10. So my program is working correctly. So we are having another example for a calloc. The same logic. A user, okay, integer k star p j equal to 0, sum equal to 0. As a print of how many numbers I'm storing it in the variable k, p equal to integer star calloc k comma size of integer. Okay, so 5 elements means, okay, 5 blocks as well as each contain the 2 bytes will be allocated. Why j not equal to k? That means what happened? actually j is 0 initially. J is equal to 0 is not equal to k. So equal to print. I ask the user print of enter the number j plus 1. That means what will happen? It will display enter the number 1. It will be stored in the memory location p plus j 0th. Okay, base address. Then j is become 1. Okay, it will ask the user enter the number. Okay, first 2, second element. Okay, then it will store the memory location p plus j. Okay, it means actually the very base address plus 1. Okay, second element will store consecutive as we discussed. All the elements are stored here. Again, I'm initializing it j equal to 0. I'm for writing a loop for j not equal to k, sum equal to sum plus j is 0 now. Make sum equal to sum plus star p plus j. So j is essentially 0, p is the base address. Okay, the element in the base address will be retrieved and stored in the sum. Okay, sum 0 plus the value and stored in the sum. Then j is become 1. Okay, this will find the first element. Okay, memory address plus 1. Okay, for the second element, and it will be added with the first element and stored in the sum. Likewise, all the elements are added until j is not equal to k. Once j is equal to k, it will come out of the loop and will print the sum. We'll run and check the program. Totally 5 elements: 10, 20, 30, 40, and 50. So total sum is 150. Okay, 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100, 100 plus 50, 150. Okay, this is another program for example of the calloc function. Okay. Now we will discuss important realloc function. Realloc function, if the previous allocated memory is insufficient or more than required, you can change the previous allocated memory using realloc function. For example, if you are allocating memory using malloc realloc, memory is not sufficient. For example, you are allocating memory for to store the 5 integer variable, but you are supposed to store 10 variable means you have to reallocate the memory will increase or decrease. Our memory is uh, okay, the memory is insufficient or more than required. We will trim it or we will add more space by using a realloc function. Okay, the syntax is pointer variable equal to realloc the pointer variable comma new size. Pointer ptr pointer always play always point the base address. Okay, we'll discuss an example of the realloc function. So I am declaring a pointer variable and I and two variables n1 and n2 are the integer variable. Enter the size of the array. I get the size of the array into n1. So I allocate the memory. Okay. So integer star equal to malloc n1 number of elements in size of integer. Address of the previously allocated memory. Okay, I'm printing the address. I equal to 0, I less than n1, I plus plus. Percentage u slash n means okay the memory variable. PTR plus 1 means the base address plus 0. I is equal to 1 means okay base address plus 1 second element. Okay, second memory, third memory. So wise the memory from 0 to n minus 1. Okay, base address plus up to n minus 1 all the address will be printed. Okay. So enter the new size of the array. What I'm doing, I ask the user to enter the new size of the array. That new size is stored in the n2. Okay, I'm array allocating memory for the realloc point variable ptr plus n2. But new size is allocated to point variable. I'm printing it. I equal to 0, I less than n2, I plus plus. What I'm doing, I'm slash n percentage u slash t. Okay, tab space ptr comma plus I. So memory. Okay, new allocated memory will printed here. We'll run the program and see the memory spaces allocated memory address. Okay, initially I want to enter three elements. So three memory space allocated 280, 284, 280 memory location allocated. New size. I want to store 5 elements now. What will happen? So its memory is increased. Base address, first element, second element, third element, fourth element, fifth element. Okay, each will contain 4 bytes. So initially for memory is allocated for the three elements. Okay, three elements. These are the memory address. Now I increase it to 5 elements. So these are the memory address. So I increase the memory address in runtime. Okay, not in the compile time. Next, as we discussed, free function, which used to allocate the free the memory which is allocated by the malloc and calloc function. The free function used to what it will do? It will free the memory. Okay, we'll see the example. So what I am doing, I am declaring a character pointer, allocating memory variable. Types of characters are malloc 6. Okay, I store the value in the base in the by using a pointer variable India. Okay, so totally 1, 2, 3, 4, 5. Okay, the 5 elements will be stored. Okay, I will print the values string equal to percentages str. Okay, that means that okay, value India will be printed. Now I want to put Hindustan. Memory is not sufficient because Hindustan is 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 9 characters are there. We cannot store it in the memory space of 6 character. So I'm increasing. String same pointer variable equal to character star realloc of the pointer comma 10. So memory space is increased for 10 variables now. Okay, each will carry 1 byte. Okay, string copy Hindustan. Okay, what will happen? It will show Hindustan. And print of now str equal to str means now the string will print the Hindustan. Get check means okay, it will hold the screen until a particular character is entered. That is essential for Turbo to see the result in Turbo C++, but in code block it is not essential. So I'm removing it. Okay. Now I run the program and check the result. So initially, what will happen? Initially, the string allocated for Hindustan. Okay. Initially, it is India. Now memory is increased. The string is accustomed to Hindustan. Dynamically, the memory is increased using realloc function. So finally, what happened by using free? Okay, free str means actually the memory is released. Now you want to print str print of str equal to percentage u comma str. We'll check it out. Okay, it will print some garbage value only. Okay, the value will not be there because memory is released. Okay, that's it for the class. That's it for the class. Thanks for watching it.